and today we're going to discuss about network intrusion detection. It's a technique used to identify unauthorized access or malicious activity on a computer network. There are two main types of network intrusion detection. It's a signature-based detection and anomaly-based detection. The signature-based involves looking for patterns or signatures of known attacks, network traffic. This uses a predefined rules to compare network traffic to a database of known attacks. If a match is found, the intrusion detection system generates an alert. And in anomaly-based intrusion detection, it detects abnormal or unusual traffic network that deviates from expected behavior. It involves statistic methods to establish a baseline of normal network traffic. And when a deviation is detected, the intrusion detection system generates an alert. The modern intrusion detection system uses a combination of signature-based and anomaly-based detection techniques to improve detection accuracy and reduce false positives. Intrusion detection systems can be deployed in several ways. It's a host-based intrusion detection, network-based intrusion detection, and hybrid intrusion detection. In host-based intrusion detection, this method involves installing intrusion detection software on individual hosts. And in network-based intrusion detection, you gotta use detection sensors on the network to monitor traffic as it flows through the network. In hybrid intrusion detection, it involves combining both the host and the network-based intrusion detection techniques. And coming to the next slide, the problem statement. Our objective is to build a network intrusion detector, a predictive model capable of distinguishing between bad connection and a good connection. By using around 5 machine learning algorithms and a deep learning model, we classify the intrusion attacks and using various methods such as PCA to reduce the dimensionality of the large data. Next slide. The data set is the KDD Cup 9090 data, which has 42 features and 49400 instances. It contains 5 class labels: normal, DOS, probe, U2R, and R2L. It has 22 attack types, out of which we have selected 4 attacks. It's Neptune, back, virus client, port suite are the attack types. Coming to the next slide. The attacks fall into the 4 main categories. It's DOS, denial of service, example, SynFlood, probing, which is surveillance and other probing, example, port scanning, and another one's R2L. It's unauthorized access from a remote machine, example, guessing passwords. And the last one's U2R, unauthorized access to local super user privileges, example, various buffers. And coming to the next slide.
Yeah. Rupendra, can you please go back to the before slide? Yeah, methodology. Yeah. Hello all, I'm Shravan Kumar Gaud Baikadi and my UH ID is 22129888. As part of CIS6397 project, I'm going to discuss about the methodology, libraries used in the project, the data pre-processing and model training. The methodology of intrusion detection network involves data processing, in which we do data cleaning, normalization, and feature selection. And we'll split the data set into training set and test set in the proportion of 80-20. And in model training, we have used the 6 models such as naive Bayes, logistic regression, SVM, KNN, artificial neural network, and random forest. And after that, uh, we have model testing and then evaluation of metrics. That's all about the methodology. And in the next slide, the libraries used in the project. The libraries are OS, a default dictionary, pandas, NumPy, matplot library, warnings, sklearn, datetime, and cborn. And in the next slide, coming to the next slide, the data pre-processing, which is an important step involved while dealing with data sets, is to clean the available data before using it for data analysis and building models, which involves removing or inputting null values or removing duplicates. And some of these features in the data has outliers. Those are removed by using IQR method, in which the values that are less than minimum are replaced with the minimum value, and the values that are greater than the maximum replaced with the maximum values. And also we did the normalization and one hot encoding, which I'll be discussing in the next slides. We split the data into train and test as discussed before, 80-20 proportion respectively. Yeah. And coming to the next slide, uh, in this slide I'll be discussing about data normalization and one hot encoding. The data normalization is a data processing technique used in the data analysis and machine learning to transform data into a standard format that facilitates the comparison and analysis of data. The goal of data normalization is to reduce redundancy and eliminate anomalies in the data by bringing it into a standard form. Normalization involves scaling the numerical values of a data set to a common scale, usually between 0 and 1 or -1 and 1, without changing the relationship between the values. This can be achieved through several techniques such as min-max normalization and z-score normalization. Min-max normalization is a technique which scales the data to range between 0 and 1. It is calculated by subtracting the minimum value of data from each value and then dividing the range, which is the difference between the maximum and minimum values. And coming to z-score normalization, this technique scales the data to have a mean of 0 and the standard deviation of 1. It is calculated by subtracting the mean from each value and dividing by the standard deviation. In this project, we have used the min-max scaler for normalization. And also we have one more normalization called decimal scaling normalization, which scales the data by shifting the decimal point of the values. The number of decimal values to shift depends on the maximum absolute value in the data. Basically, normalization can improve the accuracy and effectiveness of machine learning algorithms, particularly those that use the distance-based measures such as KNN, which is a K nearest neighbors, and SVM, support vector machines. Normalization can also reduce the impact of outliers and make the data more interpretable and easier to compare. However, it is important to note that normalization should only be applied to numerical data and not to categorical data. And coming to one hot encoding, it is data transformation technique used in machine learning and data analysis to represent categorical data as numerical data. One hot encoding is used to convert categorical data into a format that can be used by machine learning algorithms. Many algorithms require input data to be numerical. So one hot encoding provide a way to represent categorical data in a way that can be used by these algorithms. And in the model training, we have used the 6 algorithms. I mean, the next slide. The algorithms are naive Bayes, logistic regression, SVM, which is support vector machines, KNN, K nearest neighbors, ANN, artificial neural networks, and the random forest. Yeah, that's all from mine.
Hello, Professor. Hello, everyone. My name is Rupendra Lekkala, and my UHID is 2211969. I'm going to explain about different types of models we trained for the KDD 99 cup dataset, which are naive Bayes algorithm and logistic, and then SVM, and then K nearest algorithm, and then artificial neural networks, and the last one is random forest. So going to naive Bayes. Naive Bayes is a probabilistic machine learning algorithm that is commonly used for classification problems. The algorithm is used on Bayes theorem, which is fundamental concept in probability theory. The naive Bayes refers to simply assumption that features in the input data are independent of each other, which is often not true in practice. Despite this in simplification, naive Bayes can still perform well in many real-world applications. In this classification problem, the goal is to predict the class of a given input based on its future. Naive Bayes works by calculating the probability of each class given by the future of the input. The class with highest probability is then chosen as the predicted class. So the test data has 36,397 data points, which has a normal connection and bad connection. And naive Bayes classified 99% of normal connection points correctly, and Neptune has had the highest number of bad connection points, which is 12,955. and 99.99% were classified correctly. Other classes where few data points had varying classification accuracy ranging from 0 to 100. Nameless classifier achieved a F1 score of 96%, and the false positives were 710 points, which is 0.049%, and train and test score was similar and high, indicating the model is neither overfitting nor underfitting. So this is the confusion matrix and classification report. Here we can see the NIBASE classifier, the accuracy is 93%, and we can see the precision, recall, and F1 scores here. And moving on to next slide, which is logistic regression. A logistic regression is logistic regression is a statistical and machine learning algorithm used for binary classification problems, where the goal is to predict the binary output variable by based on set of input variables or features. The algorithm models the probability of the binary output variable as function of the input variables. Logistic regression, the output variable takes two values, usually 0 and 1, corresponding to the two possible classes or outcomes. The algorithm estimates the probability of the output variable is equal to 1 given the input features using logistic functions or sigmoid functions. So in the we splitted the data into 80-20 percentage as training and test data, and then we fit the model with training data and test data, and we find the best model using grid search with different hyperparameter initialization, and then we fitted the model, and we got the accuracy of 97%. And here you can see the confusion matrix and classification report, which shows the precision, recall, and F1 score. And then moving on to next model, which is SVM. SVM classifier is a support vector mission, is a popular machine learning algorithm used for both classification and regression tasks. SVMs are particularly well suited for classification problems where the goal is to predict the class of an input based on a set of features. The basic idea of SVM is to find the hyperlane that separates the data points of the different classes with maximum margin. The margin is the distance between the hyperplane and the closest data points of each class. Hyperplane that maximize the margin is called maximum margin hyperplane. So the data points that lie on the margin are called support vector. In support vector classification, the input data is represented as set of future vectors. Each future vector is assigned to specific class. The algorithm learns a decision boundary that separates the data points into different classes. This decision boundary is chosen to maximize the margin between the support vectors of two classes. So this SVM is classified correctly with the accuracy of 99.81% of normal connections. And then bad connections like Neptune had the highest number of data points of 12,955, which is accuracy of 99.96% were classified correctly. Some of the classes were very few data points like load module, multi-hop, and so on, which are also classified not correctly. The model had high F1 score of 98%, which is outperforming the naive-based classifier. And the model had lower false positive and higher true positive than naive-based classifier. And even SVM was neither overfitting nor underfitting, as the train and test data score was similar and high. This is the confusion matrix and classification report. Here we can see the accuracy of 0.99% and the precision and recall and F1 score we can see here. And moving on to the next model, which is KNN model. KNN is a k-nearest neighbor algorithm, also known as KNN or KNN, is a non-parametric supervised learning classifier, which uses proximity to make the classification or prediction about the grouping of an individual data point. if you this is the classification report and confusion matrix, which has a accuracy of 100%. We can see here, and this is all about KNN. Now my friend Sandeep will take over the presentation.
Uh, Hello, Professor. Hello, all. I'm Sandeep. My PeopleSoft ID is 2162519. I'm going to explain about artificial neural networks and random forest and PCA, which we performed to this data set. So, in deep learning, as we have selected artificial neural networks to perform the model for this data set. So we have used Keras and TensorFlow libraries to implement this, and after implementing this model, after fitting this model, we got the out accuracy as almost 100% nearly. Could you please next slide, please? Yeah, you could see that the recall and precision and F1 score all are 100%, and in the right side we can see that receive ROC curve, which is perfectly plotted. Uh, could you please go to next slide? And coming to random forest, random forest is an ensembling learning that combines many classifiers to provide solutions to complex problems. So it is the best model out of all, compared to all different models. It is the best model, which is universally proved. Uh, so we tried fitting the random forest to the data set. Mm, Here we have split it into the 80 is to 20, as 80 as a training and 20 as a testing, and we got the accuracy as 99% as a test. As per the test results, we got the 99%, and the confusion matrix and classification report are as follows. We could see that we got the accuracy as a 99%. Could you please go to the next slide? So, and coming to PCA feature selection, principal component analysis is a dimensional reductionality using singular value decomposition of the data to project it to a lower dimensional space. So, to reduce the features in our data set, we used PCA. The input data is centered but not scaled for each feature before applying the singular value decomposition. We could see uh, the PCA algorithm in the screen, and after after applying the feature selection by PCA, we used random forest. That means like we fitted the random forest to the model, and then we got the accuracy as 100%. Yeah, this is a confusion matrix and classification report of PCA. And at the end, uh, by comparing all the results, like we could see that artificial neural networks and random forest have the best accuracy, even though we could see that all the models has similar accuracy results. It is all because of the pre-processing of the data set. So we did the pre-processing of the data set perfectly with and efficiently. So that's the reason all the results are in uh, similar accurate results accuracy, like around 98%. So thank you.